Okay, AP Stats, today we're going to look at doing z-scores and all the different normal distribution probabilities strictly on the calculator. So the first thing we're going to look at is just doing z's on the calculator. So if you recall, a z-score or a z-distribution is normal with a mean of 0 and a standard deviation of 1. So on number 1 here, if we want the probability that z is less than 1, we want this area to the left. So in the calculator, we're going to go to distributions, which you'll see above the VARS button. VARS is distribution, so we're going to go second VARS. And there's a list of a whole bunch of different distributions. Right now, all we're using is normal, and the only normal we're using is normal CDF. So we're going to go down to number 2. We're going to press enter. And your calculator may look like this. If it's not the latest operating system, it'll look a little bit different, and I'll talk about that in a second. So if it looks like mine, you're going to put in your lower bound. Mine is automatically set to -1 times 10 to the -99th. What that is essentially is negative infinity. What you can also type in is -1, 0, 0, 0, 0, 0, 0, 0, a whole bunch of zeros, so that we're talking about negative infinity. Then the upper bound is 1. The upper bound is where we are sitting here at 1, where the z is. The mean is 0, and the standard deviation is 1. We go down to paste, and it took what we just did and put that into our home screen. Now, if you don't have the current operating system, you'll just get this normal CDF with parentheses, and you're going to type in just what we did. You're going to do negative infinity. You're going to do the lower bound, which is negative infinity. So -1, 0, 0, 0, 0, 0. Just hit a bunch of zeros. I hit way too many here. That many is not necessary. Comma 1. So lower bound, comma, upper bound, comma, mean, comma, standard deviation. You'll notice if you can't find it, the comma is above the number 7. So if you don't have the latest operating system and you need to enter this whole thing in, you are entering in normal CDF, lower bound, upper bound, mean, standard deviation, and that will calculate the area for you. So if you press enter, you get the area of 0.8413, which is what we came up with yesterday. Okay, so we just did number 1. Let's go ahead and let's move on to number 4. Z is greater than 1.5. If you remember when we did this by hand yesterday, we had to find the area to the left, subtract it from 1 to get the right side area. The calculator, luckily, is smarter than that. So we're going to go back into distribution, so second VARS. We go down to normal CDF, or just press number 2. Our lower bound this time is 1.5. Our upper bound is infinity, or 1 with a bunch of zeros. Our mean is still 0, and our standard deviation is 1. Because we're working with z's, we're working in the normal distribution. So we're going to paste that in. Again, if you don't have that current operating system, you need to know how you enter it, and you enter it as lower bound, which is 1.5, comma upper bound, which is infinity, comma mean, which is 0, comma standard deviation, which is 1. Press enter, and there is 0.0668, again, which is the same numbers we came up with yesterday. Okay, number 5. On number 5 yesterday, we looked at 2.3 to 3.1, this teeny tiny area right there. When we did that yesterday, we had to find the area to the left of 2, and we had to find the area to the left of 3.1, or 2.3 to 3.1, and then we had to subtract them. Again, the calculator is smarter than that, so we just go to distributions, normal CDF, lower bound is 2.3, upper bound 3.1, mean is 0, standard deviation is 1, paste, Again, if you don't have this operating system, you need to enter in 2.3 comma 3.1 comma 0 comma 1. And we get that small number of 0.0098. So that's everything that we did yesterday, except much faster and easier using the calculator. So now what do we do with this? Why do we use this? So we're going to jump ahead to the last couple slides, starting with this one that's titled Z-Scores on the Calculator. Suppose the teachers at Lindbergh High School have an age distribution where X is normally distributed with a mean of 40 and a standard deviation of 8. What is the likelihood that a randomly selected teacher would have an age of 24 or younger? So if you were using Z-scores from yesterday and not doing the calculator, you would find the Z, look it up on the table, calculate the probability. Of course, the calculator makes life much, much easier. So we're going to graph this so we can see what it looks like. So we have a mean here of 40 and a standard deviation of 8. So this is 48 and this is 32. 48 plus another 8 is 56 and 62. On the lower end, we are looking at 24 and 16. Okay, so we are looking for someone 24 or younger. So we're looking at this little tail right here, 24 or younger. Okay, you should know from your 68, 95, 99.7% rule that that tail is about 2.5. Okay, but how do we type that in the calculator? So we're going to go back into distribution. We're going to go down to number 2, normal CDF. Our lower bound here is negative infinity. Our upper bound is 24. Our mean now is 40. And our standard deviation is 8. So you don't actually have to transform this into Z-scores. You don't have to standardize the data. You can just type it in as is. Go down to paste, press enter. If you don't have this operating system, you need to type in negative infinity, comma 24, comma 40, comma 8, and you get 0.0228, which we said was about 2.5%. So our 68, 95, 99.7% rule gives us 2.5%. This is a little bit more accurate at 2.3%. or 0.0228, depending how you round. Anyway is okay. Next one. Assuming the same distribution exists for age of teachers at LHS, how likely is it for someone to be 50 or older? Okay, so if we go back to our numbers here, and we fill in our numbers again, we are here at 40, 48, 56, 64. I think I did that number wrong last time, didn't I? Yes, I did. Sorry about that. Going the other direction, we are at 32, 24, now I'm all nervous, I'm going to make a mistake, and 16. Okay, so now we want to know how likely it is for someone to be 50 or older. Okay, so that is here at a Z-score of 1 point something-ish, 50 or older. So we're going to go to our graphing calculator and we're going to normal CDF, 50 to infinity, comma a mean of 40, and a standard deviation of 8. So go ahead and type that in. And you get 10.6%. Okay. Number 27. Now we're looking at that a teacher is between the ages of 34 and 50. We're looking at between the ages of 34 and 50. So we're going to fill in our table again. And we want to calculate between 34, well, that wasn't a very good line, 34 and 50. So we want this area right in here. So we're going to go to normal CDF. Lower bound is 34, upper bound is 50, mean is 40, standard deviation is 8. So you're going to go ahead and type that in. One thing you can do from here also is to do second enter to pull your normal CDF back up. If you're just changing one little number, that sometimes helps. Oops. And we get 66.8%. So 66.8% fall between the ages of 34 and 50. Okay, number 4, using the same teacher age distribution, at what age do 25% of the teachers fall below? So 25% of the teachers fall below. Okay, so we are looking for the lower 25%. If we're looking for the lower 25%, we need to think about where our tails are in order to draw this correctly. So we know, or we should know, that this tail gives us 2.5%. This tail from -1 below is 16%. So we need to be somewhere between 0 and 1, where that area is going to be 0.25. Okay, so we need this to be 0.25. So we're actually working backwards than we were doing before. We're actually going to type in the area, and then we're going to come up with the x value. So we're going to fill in again those same values across the bottom. So what we're going to use here is a function called inverse normal. We're going to undo the normal. We're going to put in the area so it can output the x value. So we're going to inverse normal the area to the left, which is 0.25, comma mean, comma standard deviation, and that will actually give us now the x value. So inverse normal is under distributions. It's number 3. Area to the left is 0.25. Mean is 40. Standard deviation is 8. Paste that in or type it in, and you get 34.6, which, looking at our picture, makes logical sense. So at what age do 25% of the teachers fall below? Right here at 34.6. Okay, the last slide here is at what age do 10% of the teachers fall above? So what's that looking for? It's looking for the top 10%. So we know this tail is 1.5%, or 0.15%. This tail is 2.5%. This tail is 16%. So we're looking somewhere in here for the top 10%. So for that area to be 0.1. Okay, so if we go into our inverse normal in the calculator, second distribution, you need the area to the left. So the area to the left here is 0.9. You have to be working with the area to the left. Comma 40, comma 8, enter, and we get 50.3. And again, you want to make sure that that's logical. So the top 10% of teachers are 50.3 and above. That's it for now. Good luck with the homework, and we'll work through more problems tomorrow.